Okay, let's put this all together now in terms of how do we graph rational functions. And remember that you can always use your calculator too. I think I showed that, how you can use your calculator to double check your graph. Okay, and you can use a table of values. We were showing that as well in the first example. So the first thing we're going to ask ourselves is, what's the domain? The domain comes from the fact that what can we not have in the denominator? We can't have the denominator equal 0. So what number for x would make that equal 0? So that's the number we can't have. We can't have x equals 2. So what does that mean about our vertical asymptote then? Vertical asymptote would be x equals 2. So you can go ahead and graph that. That is a dotted line where your graph is not going to pass. X equals 2 is a vertical asymptote. That's your vertical line. That's why you have x equals 2. What about the horizontal asymptote? Who can remember the rules that we were talking about for the horizontal asymptote? Horizontal asymptote, what's the degree of the numerator? It's actually 0, and that's because you have an implied x to the 0. So that right there is a degree of 0. What's the degree in the denominator? Yes, and where do you get that degree of 1? X to the first power, okay? So anytime you have a constant, that means you have an implied, you have no x's. You have x to the 0. X to the 0 is the same thing as 1. 8 times 1 is 8, right? So what is our horizontal asymptote then? Well, from our rules that we just wrote down, it was y equals 0. Y equals 0 is the same thing as the x-axis. Okay, what are the x-intercepts? In order to find the x-intercepts, it's kind of helpful to know that y equals 0. In a fraction, how do we make the fraction equal 0? We would set the numerator equal to 0. When the numerator is 0, but since 8 cannot equal 0, what's our x-intercepts? Yeah, and that's because you have an asymptote happening there. If you have an asymptote, that's where the graph is not going to cross. So therefore you can't have an x-intercept. What about the y-intercept? How do we find the y-intercept? Exactly, we find f of 0, and so we get 8 over 2, because I have 2 minus 0, which is 4. My y-intercept is x is 0. That's what we plugged in. Y, we solved for that, and we got 4. So 0, 4 is our y-intercept. 0, 4 is here. Now, I don't really have very many other points in order to graph this, so the best thing I can do is really just take my calculator and plug it in. So I'm going to go over to my calculator. I know some of my critical points. I know in general what it should look like. I'm probably going to see a curve on this side and then see a curve down here, but we can type in, I already have 8 divided by, I'm going to change that to 2 minus x. And you don't want to do 2 negative x, you want to do minus x, okay? And then if I want to see what it looks like, there's my graph. Wait a minute. That's not what the graph should look like. I didn't use parentheses. That's a good teaching moment, wasn't it? Okay. That was a linear equation because I needed to group the denominator. I want to divide 8 by all of that. So I need parentheses 2 minus x. Close the parentheses. Now when you graph it, you should see, okay, that looks better. You see where it's crossing the y-axis? Because we wouldn't have been dividing by the whole entire denominator. I would have only been, exactly, 8 divided by 2 minus x would have been just negative x plus 4, which is the same thing as a line, right? That's why we got a line. But you see how it's crossing the y-axis? Where do you think it's crossing the y-axis? Yes. Do you see how it's not crossing the x-axis? And even if we zoomed out, let's change the window. Let's change some of these. I just want to show you the end behavior. So I'm going to change the window to go out further on the x-axis. Enter graph, you can't even hardly see that, but it's getting really close to the y-axis, but we have a horizontal asymptote, so it's not crossing. Okay, now if I wanted to graph it more accurately, I don't want to just draw a willy-nilly, I want to see some points. So the best thing I can do is go to my graphing calculator, and I'm going to go to the table, and I want to see some convenient points to plot. Here's one, -6, 1. -6, 1 is here. Okay. Are there any others that are nice? -2, 2. -2, 2 is here. And I'm just really scrolling through my table. There's my y-intercept, 0, 4. Here's another point, 1, 8. 1, 8 is here. And you see how I'm getting really nice, clean points. Why is it that at x equals 2, on my table, I have an error? Why do you think that is? That's where our vertical asymptote is, right? That was our restriction on our domain. That's different than a hole. We'll get to holes later, okay? And then we have 3, -8. So we go over to 3, down to -8. And we have +4, -4, +4, -4, just plotting these points. 6, -2, over to 6, down to -2. Okay, so you get the idea. Then we're going to draw it nice and neat, put arrows on your ends. You have your asymptotes there. It's not going to cross. Okay? Any questions on that graph? Well, let's try the whole thing for another one. Okay? So the next one, now what do you think is going to be important if I really want to put that in my calculator? I'm going to have to make sure I put parentheses. We learned that the hard way. Otherwise, it's just going to take the 8 and divide it by the x if you don't have parentheses. So you're going to need parentheses. What's the domain? Who can tell me? Yeah, x cannot equal 4, right? So the domain is every single number but 4. X cannot equal 4. From the domain, you get your vertical asymptote, which is x equals 4. So we can immediately go over to our graph and say, this is where the graph will not cross at x equals 4. What about the horizontal asymptote? Who can remember how do we find that horizontal asymptote? Anybody know what it is? Yes, the degree of the numerator is 1, because that's to the first power. The degree of the denominator is 1. So we take the ratio of the leading coefficients. 2 divided by 1, that's the coefficient of 1, is 2. So our horizontal asymptote is here at y equals 2. That's a horizontal line. Y equals a number is always a horizontal line. What's the x-intercepts? Who can tell me how to find the x-intercepts or x-intercept? Solve the numerator. You're going to set 2x plus 8 equal to 0. When you solve that, -8, -8, 2x equals -8, divide by 2, x equals -4. So -4 comma 0, because we set the numerator, whenever we have a fraction, we set the numerator equal to 0, and that means that fraction is equal to 0. So -4, 0 is here on the x-axis because it's an x-intercept. How do we find the y-intercept? Set x to 0. If I have 2 times 0, the only thing left in the numerator is 8. If I have 0 minus 4, the only thing left in the denominator is -4. And what number is that when we divide? I just said it, right? 0, -2 is my y-intercept. 0, -2 is down here. And now what we should do is go to our y equals, clear out any equation you have, and type it in. Don't forget your parentheses. 2x plus 8, close parentheses, divide by parentheses, x minus 4, close parentheses, enter. Let's look at the graph. Now, I did that weird thing where I zoomed way out, okay? But essentially, you can almost see that asymptote. In fact, here's a fun thing. If I go y equals 2 on another line and I press graph, the horizontal asymptote is not part of the graph, but you can see that because it's not the x-axis this time. You can see that the graph is getting really, really close, and that's the general shape of it. And then we can go to the table, second graph. If we go to the table of values, we can start to check some of the points that we could plot, okay? So here's one, -12, 1 would be nice, although I don't have -12 on my graph. Okay, well anyway, you get the point here of how there's the -4, 0. So we see the shape is coming down here, has that X-intercept, that Y-intercept, and then on the other side, we might plot 0, -2. That was our Y-intercept. Here's 4 gives us an error, and that's because of our restriction on our domain that creates that asymptote. We can't use x equals 4. Once we cross over, we have 5, 18. Oh, can I fit 6, 10 on my graph? Kind of. 6, 10 is here. 8, 6. Go over 8, up 6. Okay, so you can kind of get the point of how you would find a few points in order to get the full graph. Any questions on graphing it using the graphing calculator or finding all those critical points?